The orbital speed of a body, generally a planet, a natural satellite, an artificial satellite, or a multiple star, is the speed at which it orbits around the barycenter of a system, usually around a more massive body. It can be used to refer to either the mean orbital speed, that is the average speed as it completes an orbit, or the speed at a particular point in its orbit such as perihelion. The orbital speed at any position in the orbit can be computed from the distance to the central body at that position, and the specific orbital energy, which is independent of position. The kinetic energy is the total energy minus the potential energy. Radial trajectories. If the specific orbital energy is positive, the body's kinetic energy is greater than its potential energy. The orbit is thus open, following a hyperbola with focus at the other body. See radial hyperbolic trajectory for the zero-energy case. The body's kinetic energy is exactly equal to its potential energy. The orbit is thus a parabola with focus at the other body. See radial parabolic trajectory. If the energy is negative, the body's potential energy is greater than its kinetic energy. The orbit is thus closed. The motion is on an ellipse with one focus at the other body. See radial elliptic trajectory, freefall time. Transverse orbital speed. The transverse orbital speed is inversely proportional to the distance to the central body because of the law of conservation of angular momentum, or equivalently, Kepler's second law. This states that as a body moves around its orbit during a fixed amount of time, the line from the barycenter to the body sweeps a constant area of the orbital plane, regardless of which part of its orbit the body traces during that period of time. This law implies that the body moves slower near its apoapsis than near its periapsis, because at the smaller distance along the arc it needs to move faster to cover the same area.